19th century, Sturm and Liouville have demonstrated that the eigenfunctions, which are the solutions of certain differential equations, form a basis for a function space consisting of functions that satisfy the boundary conditions. Well, it essentially means that any such function can be expressed as a linear combination of the eigenfunctions. And a natural corollary of this theorem is that given a linear physical system with n degrees of freedom, the differential equation of this system has special solutions which are called normal modes, and which can be thought of as eigenfunctions. Well, what makes normal modes special is that all of the physical variables in the system oscillate with the same frequency and the same phase. And in our 211 physics project, we've tried to demonstrate that the future state of any arbitrary initial condition of a coupled LC circuit can be predicted by the superposition of its normal modes.
And here is the schematic representation of the circuit. And in order to find normal frequencies of this coupled LC circuit, we first put the system into its normal modes. Since it's got 2 degrees of freedom, it has 2 normal modes, each of which has distinct frequencies, which were measured through the help of the oscilloscope. In total, 6 different frequency measurements were taken for 3 capacitors with different capacitance values. And here are the time averaged values of the measurements. And as you can see, the circuit with a 330 microfarad capacitor has the closest normal frequencies to the theoretically calculated normal frequencies. For this particular reason, it was used in the next part of the experiment, where the system was put into an arbitrary initial condition by charging the capacitors in such a way that differed from the normal mode configurations.
Now I'll show you our experimental setup. This is the coupled LC circuit that we've used, and it's made out of 3 capacitors. As you can see, they're connected in parallel, and also the circuit is made out of 2 inductors that are connected in series. And here's the oscilloscope through which we have obtained the voltage time graph.
In the next part of the experiment, after the system has been put into a random initial state, the oscilloscope has been connected to the segment of the circuit which is just next to the inductor, and the theoretical voltage was calculated to be this expression. Then the coordinate voltage time graph from the oscilloscope had been Fourier transformed to determine whether the frequencies of the harmonic waves that make up the voltage time signal match the measured normal frequencies of the system. And as expected, the error rate in both of the frequencies turned out to be less than 5%, as can be seen in this chart. In conclusion, in this experiment, essentially what we've been able to demonstrate is that given the initial conditions of the coupled LC circuit, it is possible to determine its future states by superposing harmonic waves with frequencies that has the same frequencies as normal frequencies in such a way that matches the given initial condition.